Good evening, good afternoon. My name is Patrick Arand from SKF Marine. My presentation will be a bit more technical, but no worries, it will not go too deep into technique. What I would like to talk about is some fields of operation on-site a vessel, which gives the chance to improve the sustainability with the technique on site. As a starting slide, Gavin already mentioned something about that. Thomas was talking about that. The IMO target, net zero, close to 2050 or around 2050 has to be reached. But when we look at the goals from the UN, and we are looking especially on the numbers 7, 13 and 14, we have to say that the marine industry, the shipbuilding industry has a direct impact on these goals that we reach these one until 2050. So I would like to talk about four different fields in shipbuilding propulsion systems, which are around the circulation of oil, the circular use of oil. It is about the condition monitoring that helps to reach the sustainability goal, and it is about water lubrication as one important component for that, and the chance to go fully electric with all those components which have been maybe hydraulic in former times. Let us start with the oil that we have on board. It became normal that vessels, when they are going to dry dock, they will replace the oil which is on board, not on a regular base, so they do not use it as a component that will be scrapped, so a consumable. It is going more and more into the direction the oil will be sampled. It will take a sample, it will be sent to the oil manufacturer, and this manufacturer gives the statement, yes, you can use this oil, or you have to replace it. And that means the key factor here is the lifetime of the oils that we have on board. And here there is one first step where we can go into a sustainable approach with these oils that we have, and this is the quality of the oil. The better the quality remains over the time, the longer we can use it and we don't have to scrap it. And on the other side, the elephant was in this room here, that has been the cost. We are saving the cost for the replacement of the oil. So how can we achieve this? We can use fine filtration systems, like you see it here, because the nanoparticles in the oil are more or less responsible for the aging because of oxidation. And when we can manage it, that we get out these nanoparticles out of the oil, then we can use this oil over and over again. So we can extend the replacement intervals, or when we do it right, we can use it for a really long time without exchange. And when you look at this hydraulic system you see here, you see that such a cleaning system, such a cleaning unit for fine filtration can operate aside the system. That means it's working in a kidney loop, what we say, and it can be retrofitted right now. So when we have some oil amount on board, we install such a cleaning system aside, and then we can take out the contaminated oil out of the tank of a hydraulic system, refresh it, clean it, and pump it back into the tank, and reach now a clean circuit to use oil for a longer period. And that means, what are we doing? We are taking out the nanoparticles, nanofiltration. We are taking out the varnish that could maybe clog some valve blocks and so on, so a reliable operation there. And of course, we can also take out a certain amount of water. And this will help to clean oils in several applications that we have on board. So some examples here in pictures, for example, hydraulic units from stabilizers, or the hydraulic steering gears that we have. We can look at the hydraulic power units, for example, for jack-up systems on a shaft line. So the stern tube itself, thousands of liters that we have there. And we can also look at the electric pods and the mechanical thrusters that we have with a higher oil amount, and we are talking here about 200, 400 liters for a smaller pod, for a smaller thruster, 400 to 600 for a bigger one, and thousands of liters for the different sizes of stern tubes. Other fields of application are, for example, here all commercial vessels, Navy vessels, offshore. Maybe at the end of this column here, it's also interesting, also a shipyard can maybe switch over to use cleaning oil systems or oil cleaning systems when building a ship. Further applications, passenger vessels, for example, with the elevators in there, but also engines, gearboxes, cranes, all those kind of applications that use oil are candidates to get optimized for a better sustainability and to save at the same time some costs. From the oil now to another application. We have seen the stern tube, oil lubricated in this former slide. Now we switch over to make a vessel more environmental friendly and more sustainable by using water in the stern tube. It's a common practice nowadays. Interesting here is that the kind of application is increasing. That means not only the smaller shaft lines, also the bigger shaft lines are typical candidates, and here we have to admit it is more or less a thought about when building a new vessel. What we have seen before was something that can be retrofitted. It's at once action that it can be taken. But here we are talking about water lubrication. And you see here two different setups. We're talking about closed and open systems. It is always a decision of the application of a vessel. Will it go, is it seagoing, or will it go over the ocean? Or is it more set in coastal areas with sediment impact? So it is always a decision, is it okay when we have seawater inside as a lubricant, or will we take a closed one where we have conditioned water inside? And when you look at the bearings inside such a stern tube, then you might see that the wear down, which is normal in water lubricated stern tubes, is a bit higher for the open systems, sediments, salty water, clogging, planting, and so on. And it's a bit better for the closed systems. So if you're planning to build a new vessel in a fleet, then why not thinking about water lubricated stern tubes? Another point, which is in a development stage, but is also common practice nowadays, is the use of condition monitoring systems. Condition monitoring systems, as you see here as an example, are used for those components which are critical, which are the main components, and which are key to be monitored over the ship operation time. And here this is a mechanical thruster now as an example. And what do we need for the condition monitoring system? They are the sensors. And the sensors can be from two kinds. The first one is, it is measuring, for example, vibration temperature. Why is this now looking into sustainability? Why it is looking into a green future? When we are sensoring critical parts, then it is coming up the information this part might fail in the near future or in the big far away future, but there is something going on with this component. So it gives you the chance to replace this part on an early stage. Where is now the sustainable aspect here? When I replace a part on an early stage, I get the chance to overhaul it instead of scrapping it. And that means, in this case here, these chance to repair parts before they are completely broken is given. And the second function that those sensors have in the future, for example, is the measurement of performance of parts. Here you see a sensor deep down at the prop shaft, directly behind or before the propeller, which is installed on a bearing. And this bearing here is now able to measure the load and the thrust. So where is now the sustainable aspect here? When we get a data from this bearing, and we maybe combine this with the vessel speed, with the engine RPM, or we combine it with a fuel optimization program, for example, then we can get some more information what works and what is not so performing. That means when the captain says full speed ahead, then we can immediately see a reaction in this bearing here because the thrust can be measured. And this helps you later on to optimize maybe the operation and the fuel consumption of your vessel, and this has direct impact then onto the savings of CO2, savings of emissions. From the condition monitoring, that is maybe to admit, it is a possibility to replace that in time. So that means at once. It can be taken action now. So this is not something that you have to wait for when I'm going to build a new vessel. So this might be one step into the direction of sustainability here. And as a last point that I want to talk about, it is to our experience, it is more or less the case that hydraulic systems are replaced by electric. For example, steering gears for water jets, we know this. Steering gears for water jets have been hydraulic. They will switch over now to linear electric actuators. Or another thing is a pump for tankers, which are storaging and unloading, used for that. They are also replaced by electric pumps. And what you see here is one example which is not that common on the market, but more and more stepping into this. This is an electric stabilizer. So you see here, and this is also valid for other components on the vessel, you see here the sustainability improvements, which are less weight, which are of course less amounts of oil. The only oil that is used here is the oil in the gearbox that is needed for the electric motor. But on the other side, and this has a direct impact for all this life underwater, we have less noise and we have less vibrations. And yeah, this all leads to less maintenance, is saving costs, and is a sustainable approach instead of using hydraulics with the corresponding oil inside. So as a summary, when we manage it to make things last longer on board, when we manage it to eliminate the oil on board, and when we take the chance to go electric whenever it is possible, then we are making a very big step forward onto our approach of a sustainable vessel operation. Thank you very much.